Hello, welcome back to Learn Physics. In today's topic, we are going to study with motion in a plane. Okay, so here in last class we learned about the projectile motion and the three formulas related to that we did, isn't it? Maximum height that a projectile can go, and range of the projectile, horizontal range, and what will be the total time. So these are the formulas which we derived in the last class, and last class itself I told you today we will be doing some of the numericals related to that. Okay, so in your exercise question, see in page number 87. In page number 87, the exercise questions are, see first one is a cricket 16th question. A cricketer can throw a ball to a maximum horizontal distance of 100 meters. How much high above the ground can the cricketer throw the same ball? How we can do that? A cricketer can throw a ball to a maximum horizontal distance of 100 meters. So maximum horizontal distance. Horizontal distance is called range. So maximum horizontal distance is given as 100 meter. How much high above the ground can the cricketer throw the same ball? So range is how much high the cricketer can throw the same ball. Isn't it? Same ball, if he is throwing at, what is the maximum height it can reach? Maximum range is 100 meter. So what is the formula to find out the maximum range? Range will be maximum when, in last video I told you, sine 2 theta is equal to 1. That is, range is R will be maximum when sine 2 theta equals 1. Isn't it? That is theta equals 45. 2 theta is 90 degree. That is theta equals 45 degree. So here R maximum is, so what will be the formula for R max? Sine 2 theta is equal to 1 means R max will be equal to U square by G. So what is U square? R max into G. So G I am considering it as 10. So we will be getting it as 1000 we will be getting. Okay, then what we should find out? Maximum height. Height, how we can find out? Height equals U square sine square theta divided by G. See, U square by G is equal to R max. So instead of U square by G, I can write it as 100. U square by G 100. So sine square 45. What is sine 45? 1 by root 2. Sine square 45 is 1 by root 2 the whole square. So it will be 100 divided by 2. It is 50 meters. You got it? So no need of finding out this one. If we are not finding out this one also, we can find out the final answer. Isn't it? R maximum is given as 100 meter. R max formula is U square by G. H equals U square by G into sine square theta. So instead of U square by G, we can substitute this 100 meter and into sine square 45. That is, sine 2 theta equals 90 degree. Therefore theta equals 45 degree. So in that 45 degree, what will be the height he will be reaching? 50 meters. Okay, so clear? Now it is the 15th one. Okay. The ceiling of a long hall is 25 meter high. What is the maximum horizontal distance that a ball thrown with a speed of 40 meter per second can go without hitting the ceiling of the hall? So the ceiling, the roof is at a distance of 25 meter. So while we are throwing a ball, without hitting the ball, just go. So maximum the distance it can go is 25 meter. So H should be equal to 25 meter. Okay, then What is the maximum horizontal distance a ball can throw with the speed of? Speed is given as 40 meter per second. So we should find out the horizontal distance. How we can find out the horizontal distance? U square sine 2 theta divided by g. Okay, so h is given as u square sine square theta divided by g. Isn't it? So u square, h is 25, u square is given 40 square divided by 10 sine square theta. Okay, so you will get it as 250 divided by 40 square. That will be sine square theta. So how we can find out the sine theta value? Sine theta will be equal to root of 250 divided by 40 square you will get. And then you can substitute that value, theta you find out, and substitute that value of theta. So root of 250 square is 5 root 10 divided by 40. So 5 root 10 will be 3.33 means 3.33 divided by 8 it will be. So you will be getting the answer as 0.55. So theta value equals sine inverse 0.55. Okay, using your Clark's table you can find out this theta value and substitute in this equation. U square, u value is there, theta value you will get it from there, sine 2 theta divided by g, you can find out the answer. Okay, so this is an easy and simple question, isn't it? So the next one is 29th one. A bullet fired at an angle of 30 degree with the horizontal hits the ground 3 kilometers away. Okay, so if we are projecting at an angle of 30 degree, with the horizontal hits the ground 3 kilometers away. That is, R is given as 3 kilometers and angle is given as 30 degree. Okay, and by adjusting the angle of projection, can one hope to hit the target 5 kilometers away? So whether can we make it a distance of 5, now it is at 3 kilometers. Theta equals 30 degree. So can it by adjusting its angle of projection. So can we hit the target at a 5 kilometer away. So now the distance or target is at whether range is possible for 5 kilometer. That is possible. That is the question. Okay, so what we can find out? Range is given. What is the formula for finding out the range? U square sine 2 theta divided by g. That is 3 kilometers, isn't it? So maximum range means how we can, what will be the maximum range? That is u square by g equals, what will be the maximum range that you can find out? U square by g is the maximum range, isn't it? So here how we can find out u square by g? So this is R max. R max equals u square by g. So if u square by g if we are finding out and that value is coming this more than 5 kilometers, then we can say it can hit maximum available range, that with that bullet, that only we are finding out here. So from here we can find out u square sine 2 theta, 2 into theta is 30 degree divided by g equals 3. So u square by g equals 3 divided by sine 60. Sine 60 is root 3 by 2. So 3 by 2, 3 divided by root 3 by 2. So we will get it as root 3 into 2. So that one we will get it as 3 point something only we will get, isn't it? Root 3 value if we are multiplying, we will get the value as 3.6 something only. So whether range 5 kilometer is possible? It's not possible. So because maximum range is coming in the range of 3 points only, 3 point something, isn't it? So it is not in the this range equals 5 kilometer, as that is if an object is kept at a distance of 5 kilometer away, it is not possible to hit the target. Okay, clear? So these are the important questions in your textbook exercise. So many more numericals are there. If while at the time of revision we will do all those things. Okay. So now we are continuing with our theory portion. Only one small portion is left out, that is uniform circular motion. In that we have one derivation. Okay. So now we are going to do that. Okay. Next is uniform circular motion. Okay. So circular motion and uniform circular motion. See, in translational motion or in a straight line motion, in all those things we learned about the uniform accelerated motion, uniform velocity, uniform motion, all those things we learned. But uniform circular motion, for that first we need to know about the circular motion. If an object is traveling in a circular path, if the object is traveling in a circular path, see, suppose the object is at the point A here and after some time it reaches to the point B. Okay, then what will be the distance covered, displacement, all those things we are going to find. Okay, so here in the case of circular motion, while here we are considering about the distance covered in circular motion, it will be represented as an angle. See, suppose an object is at this position A. See, if the object is at this position, in circular motion it is covering this much distance, isn't it, from here to here. So we will be considering it as an angular displacement. Okay, so that is called as angular displacement. What is the angle covered? In the case of circular motion, the displacement is called as angular displacement. That means the distance covered. Okay, it is represented with a symbol theta. Okay, this is angular displacement, angular distance covered by the displacement of the object. That is called the angular displacement. See, from the final position to initial position, if I am considering the distance, the angle, what is the angle covered? That is called the angular displacement. Okay, now it is angular velocity. What is meant by angular velocity? See, angular velocity is represented by the symbol omega. This is called omega. Okay, how we will be how we can find out the angular velocity? It is the angular displacement divided by time, or it can written as rate of angular displacement. Rate of angular displacement. Angular displacement is delta theta, change in displacement, divided by what rate means with respect to time. That one I am writing it as delta theta divided by delta t. If it is for a small displacement, that is represented as angular velocity omega. Okay. Now, whether there is any linear displacement can be considered over here. See, if I am considering the linear displacement, this is the linear position, isn't it? So in this way, if we are considering linear velocity, in which direction it will be acting? It will be acting along the tangent. It will be acting, the linear velocity will be acting along the tangent at each point. Okay, so this is the linear velocity. Linear velocity of an object which is moving in a circular path will be acting along the tangent. That is the reason, see, if we are taking a stone tied to a thread, and if we are rotating that one, and the circle, we are moving in a circular path, and after that at a particular point if we are leaving that one, what will happen? That will be continuing, it won't be continuing in a circular path. It will be going in the direction of its linear velocity along the tangent direction. See, like this, if it is moving, if we are releasing that at this point, the object will be moving like this. If it is circling like this, and if we are releasing at this point, when it is at this point, if we are releasing, it will be moving in this direction. So in which direction, which point we are releasing the object, at that point it will be this moving in that direction. It won't be continuing its circular path. Okay, so clear all those things. So now we are going to find out the acceleration. So acceleration means an acceleration will be acting towards the center of the circular path. Okay, so that acceleration is called as centripetal acceleration. So from each and every point, an acceleration is acting towards the center. So that acceleration is known as centripetal acceleration. And now we are going to find out a formula for the centripetal acceleration. Okay, so now we are going to derive a formula for centripetal acceleration. For that, I am considering an object which is in circular motion. Okay, let P be the initial point of the object, and after a time delta t, the object reached to the position Q. Okay, O is the center of the circular path. Okay, so here if I need to consider the position vector, O is the reference point or origin. So to the point P, how I will be representing the position vector is OP will be representing the position vector, vector R. OQ will be representing the position vector after a time interval delta t, and it is given as R dash. Okay, how I will be representing the displacement vector? Displacement vector should be from the initial to final position. So from P to Q, this will be the displacement vector. Representation is delta R. Clear? Okay, now we are going to draw the velocity vector for each point. For point P, it will be acting like this, V. And for point Q, it will be acting like this, it is V dash. Okay, so now it's congested over here, so I am going to draw it separately without changing the magnitude or direction. So this is OP and this is OQ. Okay, and P to Q, this will be delta R. This is vector R and this is R dash. Whatever we draw over here, the same way I drew again over here. Okay, now I am going to draw the velocity vectors. How I can draw the velocity vector? This is the first velocity vector, V, vector V. Okay, this one is acting in this direction, isn't it? So that also, without changing the direction, I draw V dash. Okay, now I'm going to give the name for this one, for the velocity vectors. So velocity vector, I am writing it as O dash here. Here I am representing it as A, and here I am representing it as B. Okay, how the velocity vector will be? Along the direction of displacement itself, isn't it? Same like displacement, we will be drawing from initial to final position, that is delta V. Okay, now we have two triangles here. First one is OPQ and the second one is O-AB. Okay, so these two are similar triangles. Using that similar triangles, we know the ratio of the sides will be equal. So how we can draw this one? Yes, OP divided by, so I am redrawing this OP like this. So this is P, OP, and this is OQ, and this is R dash. This is R and delta R. Now you tell me OP divided by O dash A equals, what is this side? OQ divided by O dash B equals PQ divided by AB. So what is, I am taking only any one, see this one, if OP means it is R divided by, so here I am taking only vector, this one, magnitude magnitude alone I am considering. So R equals R divided by O dash A. What is O dash A? V equals OQ. What is OQ? R dash divided by O dash B is V dash equals PQ is delta R divided by delta V. Okay, so what is, see, R dash means it will be the, yes, it is inside the circle. So R will be equal to R dash. So it will be R dash, we can write it as R, and V dash we can write it as V. Only direction will be changing. Okay, all others will be same only. So here we can write instead of this one. So any one we can write down. So I am considering R by, so I am neglecting this. R by V equals delta R divided by delta V. Okay, so I am rewriting this as R equals, so delta V equals delta R by R into V. Like this I am writing. Okay, so if we are rearranging this one, delta V, now I am limiting this value delta t tends to 0, dividing it with the delta t. Limit delta V divided by delta t equals limit delta t tends to 0, delta R by delta t into V by R. What is this limit delta t tends to 0, delta R by delta t? It is instantaneous velocity. So V into V divided by R, that is equal to V square by R. What is this limit delta t tends to 0, delta V by delta t? That is acceleration. So in a circular motion, acceleration we got it as V square by R. In which direction it is acting? It is acting towards in this direction. That means it is acting towards the center. It is acting towards the center of the circle. So centripetal acceleration will always act towards the center. The formula for centripetal acceleration is given by V square by R, which will be acting towards the center. Okay, clear? This formula, it's an important derivation. AC equals V square by R. Okay, so this is centripetal acceleration which is acting towards the center of the circular part. That is called as centripetal acceleration. Okay, now what is meant by uniform circular motion? Uniform circular motion means, see, in a circular path, if the object is moving with a constant speed, we are not telling velocity. Why? Because velocity will be changing. Velocity will be changing at each and every point, isn't it? So we are not considering the velocity, we are considering the speed alone. Okay, the object which is moving in a circular path with a constant speed is called as uniform circular motion. Okay, clear? So centripetal, this is the formula. This is how we will be finding out the formula for V square by R. AC equals V square by R. Okay, clear for you? So I am winding up for today. I hope all of you understood all those things. If you like the channel, please don't forget to subscribe. Okay, thank you for watching. Bye.